Hi everyone, hope that you're all doing well. In this short micro lecture, I want to give you a sense of how to tackle your data analysis projects from beginning to end, basically. I got a lot of feedback in the project proposal section on the difficulty people were having with figuring out what resources exist for the project. Some people were under the impression that there are no resources for the project. Some people saw the many resources that are available, but felt a little bit overwhelmed by them. So today I wanted to show you about 30 minutes worth of a discussion of how to effectively use the large but I think manageable number of resources with which we've provided you. I don't want to sound too grumpy here. I know that many of you who are in the class were robbed of these normal learning and maturation experiences in the last few years. But I do think, this is the fourth time I've taught this course. I've every single time made the instructions clearer, more concise, and also provided more resources in a well-formatted and organized way. And every semester I started teaching, around the time that I had students that had no COVID high school experience. And then every year I've had more and more students that had COVID high school experience. People have had more trouble as the instructions have gotten clearer, more concise, and I think more useful. So I don't mean to be a grump about this, but I've noticed that people are having kind of more trouble with this sort of thing, just reading an instruction sheet and then looking and seeing what resources exist. So I wanted to provide a little bit of a friendly push in the right direction here. So step one is to read the introduction to the instructions, which I have conveniently provided for you as a screenshot here. And I want you to know that all images in this section come from existing resources, with one exception that I forgot to mention. But basically, these are things that you have access to. Where these things live is in the course drive, which is accessible through the front page of Canvas. Hopefully you know where this is. So let me just show, this is the way you would get to it from the Canvas link. This is the main page of the course drive. This is data analysis project folder. This is the first project. And then here you've got the instructions. Then you've got guides for each of the 4 types. You only really need to look at one. I would recommend downloading this one as well. I put it basically, I put the kind of workflow material together with one example on quantitative predictor and one example with graphics. And the reason I put them together like that is it doesn't make a lot of sense to have a workflow do file and a graphics do file without some analysis. So I chose to put it with the regression analysis. So you probably want to download that one no matter what. But otherwise, you only need to pick one of these 3 if you have any of the other 3 types. And then here's a link to the tutorials on YouTube. You can just, I couldn't figure out how to put a YouTube link in here, so you can just put this into the browser. So just like this, tinyurl.com/data fundamentals. And all this is a redirection website where you can take annoying URLs and turn them into URLs that are catchy like that one. So that goes to the tutorials. And then this finally here is basically a subfolder that we'll use later on that shows you how to put things into your final report. Okay, but I want to explain what all that stuff is here. So the next point was that I was a little taken aback by how many proposals ended up really kind of off base on the variable types. So people were saying that they had variable types that were the exact opposite of what they had. That is one of the easier things we've learned. So I really would like for people to double check that you understand which are quantitative and which are qualitative variables. I don't think it's terribly hard. Very short summary. If the numbers that someone gives to a variable make sense and are unambiguous, so if someone says, record the income of the people in the sample in dollars, there's going to be very little debate about how to do that. I mean, defining income is a little bit hard, but what you could say is, your hourly wage at your primary job. That's a little more specific. There's not going to be a lot of debate about that. Yes, there might be some strange cases with tipped workers and that sort of thing, but, in principle, it's not terribly hard. Or, another example would be someone's age or the number of years of education that they have completed. Again, there could be some, strange cases for sure, but for the majority of people, the number assignment there is not going to be a problem. Conversely, something like religion, you can assign numbers to religion for the sake of convenience. So write down a 1 if the person's Protestant, 2 if they're Catholic, etc. But note that that's just an arbitrary way of doing it. There's many other ways of doing it. There are more formal criteria for what makes something a quantitative and a qualitative variable, such as the demand that a quantitative variable have even spacing between all of the values of the variable so that they can be assigned to numbers. There is no spacing or even directionality to the religions, Protestant, Catholic, Jewish, agnostic, Islam, Hinduism, etc., right? So there's not even a direction, let alone even spacing. It can't be a quantitative variable. It can't have a meaningful 0. It's not a quantitative variable. But just to keep it really simple, if you are having trouble with this, in theory, it should be something that you probably have understood on some level since high school. So just kind of use your intuition there. Something like religion or sex or race or region, these are not quantitative variables. You can't assign numbers to them in a way that makes sense when you use them numerically. Now, there are times where you want to assign numbers, such as when Stata effectively requires you to. Not always, but in Stata, it's almost always easier to give arbitrary numbers to the values of a qualitative variable. But you should still use those variables only in ways that make sense for qualitative variables. So you just assign the numbers for convenience. And many surveys, such as the GSS, do this automatically. They assign numbers to the values of qualitative variables just for convenience, but that does not mean you can use them as quantitative variables. And then you want to make sure that you understand that usually, if not always, the techniques that work for one of these things are not advisable for the other. So maybe some people, got the names of the types of variables correct, but then chose strategies that make no sense. So again, would you want to do a scatter plot for religion and race? Absolutely not. That's a numeric technique. It makes no sense for qualitative variables. Would you want to use a two-way table for someone's income and years of education? No, those are both quantitative variables. That two-way table will have tons and tons of individual cells. It will be impossible to interpret. If we could do that, techniques like regression would have no purpose. In fact, one reason that we use a technique such as regression is because you might want to use a two-way table and then you run into that exact problem. That's a way of understanding what regression does, actually. Okay. So that's that. I don't mean to sound too grumpy or anything. I was just a little surprised. Many people, I'd say probably about more than half of people got this wrong, like identified the wrong types of variables that they were suggesting. So I just wanted people to kind of go back and review those things. I feel like people have done well on certain tasks and assignments that are much harder. So maybe this is just a case of people turning in things at the last minute, trying to get some participation credit. But I think for your projects, which are not graded on participation, but on accuracy, I think it's a good idea to go double check these things. Okay, so once you have that feedback, you've taken it seriously and made the necessary adjustments, then you need to do the analysis. So here's a decision tree for you. How good do you feel about the Stata component? If good, then go ahead and do the steps laid out here to the right. If not so good, follow the example do file and then watch the tutorial on them. This part does not need to be directly written up, meaning that this is just a guide to how to do the analysis, and the parts that you do need to write up come later. So don't do two write-ups, as some people have done in the past. There's a difference between the guide to doing the analysis and the guide to writing it up. You only need to do the write-up part, but the guide to doing the analysis you may want to follow because there are things you may want to do that you don't need to explain every detail of, or that you're going to explain the details of, but in some way that is different in the writing process than it is in the research process. So what does the analysis require you to do? You have to select these variables, as we already said. You need to formulate a research question and a hypothesis, which you've already done. And then what you need to do is provide some basic descriptive statistics for the variables. Note that for qualitative variables, some of these measures don't make sense, as we've said over and over again in this class. In the original set of the instructions, I didn't painstakingly point this out because I thought this would be obvious, but I probably should put a footnote on kind of any time I say this now. So yes, don't take the mean of religion. Don't take the mean of race. Don't take the standard deviation of whether or not someone is a citizen in the United States or not. Actually, that makes sense because that's a dummy variable, but it still needs to be dummy coded. But if it's something like someone's citizenship status where they have citizen, green card holder, permanent resident, etc., then don't take the mean. So don't take the mean of anything that's not a dummy variable, which is technically a quantitative variable anyways. So we can call it a quantitative variable. Don't take the mean of anything that's a true nominal variable, right? Or an ordinal variable for that matter. So you need to present these in nice looking titled tables, and I'll talk about how to make the tables actually look nice later on. That part can't be done easily in Stata, so we'll come back to that. Then you want to present a graphical analysis of each variable's individual distribution. Again, you need to think about what's most appropriate in your case. Histograms and bar graphs aren't the same thing. You want to think about, should I do a histogram or do a bar graph? Then you need to do your bivariate analysis. Once again, you need to put this in a nice table and think about all of the things that you should report in this situation. So don't just put up a bunch of kind of random information. you need to restrict yourself to meaningful information, and or all the information that you'll get from Stata is meaningful. You need to restrict yourself to information that you understand and can report, and then you need to present a graph of that relationship. Then you need to get all those things later on into a nice Word document, but we'll come back to that later on. And finally, you also need to turn the Word document into a PDF, but we'll come back to that. Okay, so how do you export those tables and graphs? This is the only part that doesn't have a lengthy explanation in the instructions, on which we haven't spent a ton of time. So last semester I made a supplemental document on this, but labs will also go over it in the week before the projects are due. In the meantime, for making the graphs look nice, you can see code, which is at the end of each file. Then also this tutorial here, this is in the fundamental data analysis playlist that I made, but it's the final item here. So publication, quality, graphics, and Stata. You only need to watch up through about the first 20 minutes. You can see here that, like I said, about minute 21:38, I go into some explanatory material that isn't strictly necessary, and I think I even put it up here. Yeah. So basically, you don't need to go any further than that, although you're certainly welcome to. It's a convenient way to produce many graphs that I use in this class, but you don't need to do it if you don't want. Okay, so that's that. And then to export tables and organize them in your paper. And remember, graphs are different than tables. Graphs basically happen in implicit coordinate space, and they include things such as histograms, bar graphs, scatter plots, spine plots, and the whole like. Tables, by contrast, are just filled with numeric information. I'm actually kind of thinking now about how I would formally distinguish a graph and a table. It's actually a little bit difficult to say very precisely what distinguishes them, but hopefully this is more or less intuitive to you. So if it's a table, it's really only got numbers, and I guess what I would say is their geometric or their kind of like map layout doesn't matter quite as much. So to export those tables, see this folder here, which has a demo for every project type, and I'm going to show that in just a second. The idea, though, is that you want stuff to look like this. You don't need to put quant, qual, qual. Again, I'm going to try to footnote absolutely everything because I know some people will misunderstand this. This is just in the guides. You should not put this in your paper. And these are for the 3 most common project types. Now, this does not have absolutely everything that you would want. For instance, for the quant variable, I did not have space to show the regression analysis. So you need to go and look and see, okay, this only has univariate analysis. I need to go do the bivariate part. Here, for the qualitative variables, I had space for both, and I just chose to do both because they happen to be right next to each other. And the same is true here for quantitative predictors and qualitative outcomes. This is just the bivariate analysis. You need to pair it with this here. So please be aware of that. I know, again, inevitably someone will say, even though I'm saying all this stuff, that they thought that this is all they needed to include, but you have to read carefully. Go check out the original document. Let's look at the original document. So we're actually going to look in the Google Sheets file here. And what this shows you is a way to basically convert Stata output into something that actually looks nice, because Stata is, unfortunately, this is a bit of a minor scandal. Stata actually does not have an easy kind of native way to export its output, which is a signal failing of Stata. So what you want to do is actually get your output and then copy paste it into an Excel sheet like this. So let me show you, here's my example, right? But let me show you an example of how to use the example. So what I would do is this, I would download this or make a copy. So let's say here, copy. I'm putting this in this folder here, but you'll have to copy it somewhere else because you don't have access to this. Pause. Okay, so now our copy is loaded. Let's say that we're doing not an analysis with education, father's education. Let's say we're doing an analysis with, let's say, mother's socioeconomic index and respondents. So how would we do this? Well, first we need the summary statistics here, and these are the ones that you should print. So we could say sum SEI 10, ma SEI 10, like this. And this part's going to be a little bit tedious, but this is just part of it. You know, there's not really a much easier way to do this. What I would recommend is trying to do something like this, where you toggle the screen so that you can you don't have to keep tabbing back and forth. And we can see here, how did I set this up? Yeah. We'll try to do, okay, we'll come back and do the ends later. Okay, so the mean we'll just say is 46.94. Standard deviation is 23.03. And okay, it looks like we actually need to do the detailed summary statistics. So we can pull that up like this, get it for SCI 10. Okay, so Q1, we tab this over a little bit, was 25.2. Q2 was 41. Q3 was 65.45. 65.45. And then our minimum was 10.6. Our maximum was 92.8. And N was 2248. So that's how we would do that. I'm not going to tediously do that for mother's socioeconomic index, but you get the point. Then we would go change this here to, this is just respondents, so SCI 10. Then we do the bivariate analysis. So let's say we're regressing as would make more sense. Respondents socioeconomic index on mothers. So we would say like this. And remember that if we don't want this extra output up here, which is extra for now, we'll learn more about it later, although we've already learned some about it. We can just write the option no head here. So then what we have is this regression equation here, which we can make sense of. Why don't we just write it in the command window so that we don't need to keep tabbing between windows? This is not actual code, but we can basically say this. So we can say display the regression equation is 0.25 times ma SCI 10 plus 37.56. Okay, so now we can just pop this in here, and we generally should italicize, or you can use Courier New, this font here, either is fine. This, and then R squared, we come back here, and oh, okay, R squared was not actually in this output. We could either run the full output, but remember that you can also literally just square the two like this, and then do this, and we get 0.06235. We can just say 0.06. Let's check. Okay, that does match this here. So R squared equals 0.06. And that's how you do that for quantitative analysis. Okay, so let's assume now that we have a qualitative analysis. The first thing to note is that you may want to report means here and standard deviations, but only if you have dummy variables. And I showed how to make these two dummy variables here in the project tutorial. You should only use means and standard deviations in your reporting if you have dummy variables, aka binary, indicator, Boolean, etc. If you don't have dummy variables, as I tried to point out painstakingly here, although I know it's very easy to overlook this, but I want you to really try not to. You should not, in that case, then include these summary statistics. What you should do instead is just tabulate the variable like this. So how did I get this information here? Well, we would have done something like this. Whoops, I think it's marital. I'm thinking of another data set, yeah. So we would do something like this, and we could just copy this in, right? So we see, okay, we have N998 here, which came from here, copy these. You don't need to put the cumulative, which is what this stands for, percentages, because they're sort of arbitrary. It depends on the ordering of these values. But that's how you would get that in there. And then, okay, we did the analysis of non-Protestant and Protestant, and we got a two-way table. I haven't made the variable Protestant in this data set. It's in a do file that I have, obviously, and have made before, but I'm going to be a little bit concise here and just pick a random variable. So let's say tab marital, ab any, whether respondent thinks you should be able to have an abortion for any reason. We'll take row percentages, and what we should do here is then just copy paste these so that we can say, and in fact here what I would recommend is putting percentages in bold and then raw counts in parentheses in plain text here. I wouldn't do it like this here because this is actually a little bit harder to read. It's better to use different typefaces, I think. So that's how you would come up with the two-way table, and you should make sure to percentage it the correct way, etc. For quantitative, qualitative variables, you should first of all be in contact with us if you're trying the qualitative outcome and quantitative predictor. This, however, is for qualitative predictors and quantitative outcomes. For the univariate analysis, just combine techniques from above. So if you have a dummy variable that's a qualitative predictor, you can report the mean and the standard deviation. If you have a non-dummy variable qualitative predictor, just print a frequency table like this. For the quantitative outcome, you can just print summary statistics like you did for the quant up here, or like you would do. You don't have to do both. And then what you would do is then print a table that has the mean, the conditional mean conditional on the values of the predictor variable here. I'm not showing like every single possible case. I hope it's obvious that if you had something like, say, marital status, you would say, instead of the mean income by these two possible values here, you would do it for all of the marital statuses. I hope that's pretty straightforward. If not, you can contact me. Some of this just requires like a teeny tiny bit of extrapolation that I hope is within people's capacity. Okay, so let's say that we've done that now. Then what we would do is paste this into a word processor. So Google Docs is an example of that, but so would Microsoft Word be. So all you have to do, this is really straightforward, is do this. You just like pretend you have some writing here, and then you would say, okay, let's say I want to put in this table. Oops, we'll do this here. So I copy this. Sorry, wrong folder. I paste this. You don't need to link to a spreadsheet. In fact, you shouldn't paste unlinked. You can delete this here that we don't really need, and then you can kind of stretch this out. So this looks nice, and then you would just title the table. And then italicize it, which is standard practice. And then this is really all that you need to do. The way that you would write up the findings is given right here. You're going to need to adapt this. Your situation may be more complex. You cannot simply swap out my numbers here. You need to think about your own analysis. And you probably should round a little bit too, but otherwise this is the basic idea. Okay, the same would be true. It's just copying a table down here for the other instances of copying tables. For graphs, what you should do is take a screenshot. So you can just produce a nice graph. Let's get a nice graph from, by the way, we're going to delete this here. Let's get a nice graph from the data analysis project example do file, since I don't want to rewrite all of that here. Let's grab it from this here. So I'm going to download this here, and we're going to skip some of this material here. Let's come down to where I make the fancy graph, which is down here. So, ooh, doesn't look so good. Let's add, change the scheme. Okay, this is better. So this is what we want. Now you don't need this regression equation up here, but you could put it in there if you want. I explain how to get it. Now for this, you can do a couple of things. First, you can save the file, and I would generally speaking recommend doing that. But you can also just take a screenshot. The reason you can take a screenshot here is that these actually look nice and you can modify them in Stata. It's very difficult to modify tables in Stata. Yes, it's stupid. Yes, other software can do this better, but that's fine. So take a screenshot, and then you can slide that to the side to get it to expedite. And then all you need to do is remember where your screenshots are stored. In my case, it is in a special folder because I don't like having them on the desktop. So I know that they happen to be in the screenshots folder. I grab it here, and then you should put a border around this so you don't just have white on white, which notice this is very hard to read because it's not clear where the graph stops. So then you want to do this like this, right? And that's basically good. And you can see that's how I got this here before. So make sure you put a border around it as well so it's easy to read. Again, this is my kind of preferred house style, but I know what I'm doing and I've been doing this for a long time. So I'm asking you to just, before you try something different, see if you can just match my results. Okay, so that's fundamentally how you would do this. It does not change for these other types here. All right, so that's how you export tables and graphs. And this is just stuff I said out loud. Here's an example of what this looks like. This is from an actual student, Megan D, who's in the class last semester. And her paper is one of the example papers that I'll post for quantitative analysis. And Megan had not taken a course like this prior. I think she, did especially well in the course, but she was not a grad student. This is not someone that had a ton of prior knowledge. She just was able to figure this out. So she did an exceptionally good job, but I did want to stress that this is within all of your grasp here. She just followed the project instructions very carefully, and she was able to get this looking. This is not my stuff. This is stuff that came right out of her paper. So this is within your grasp. Okay, the next thing you want to do is write the report. And you can basically follow my exact layout here. Note that this is going to be very similar to what you did in the analysis portion. So I'm not asking you to redo a bunch of work, but this is just a guide to writing the paper as opposed to actually doing the analysis. So you only need to write one report with these components. Every semester, someone tries to separately write up the analysis part. Please don't do that. This is not meant to give you double work. It's just that you should do the research and the write-up separately. They're closely related, but there's an efficient way to do one that's not the most efficient way to do the other. If you have trouble with writing specifically, please see the Writing Center. We can help you all up to an extent, and I think your TAs and I model clear communication and good writing in this class. For example, I write all of my lecture slides out in clear, virtually always grammatically correct English with proper spelling, and kind of lively, engaging writing. But that said, it's not a writing class, and I can't do much more than that. So please see the Writing Center if you have trouble with that. It's totally fine if you do. No one's making fun of you or mad, but it's just not a class in that. And I'm saying that as someone who has taught writing and served as a copy editor for actually many years of my life. I edited a poetry journal in undergrad, so I have no disinterest in writing whatsoever, but I'm just at this point in my life, teaching very different stuff. And it's just not a class in that. So please do see the Writing Center. They're really nice folks. I know a lot of people that work there. They're very, very kind. And it's free. Okay. But this is the structure. So basically, in the introduction, give the research question, state your hypotheses, discuss the relevance or importance of your research question. So not too hard, right? The data and the methods. You want to describe your data and its survey design. Please don't skip this over. You do need to be a little bit familiar with where the data come from. So we will take points off for this because I do think it matters. You need to go take a look at the GSS basic website. There's hints given throughout the, in fact, there was actually a homework question about this that told you exactly where to go to read about this, making it very, very simple. You just need to restate what they said in your own words. We're not using survey weights in this class. You don't need to do anything about the stratified random sample. But that said, I do want you to just be apprised of it. Then discuss the operationalization of your variables. Operationalization was a hard word for some people. What it means is just making something concrete that is abstract. So you need to go figure out not figure out, you've already figured out, but you just need to say, how did the researchers turn this into an actual question they could ask people? You should consider looking at the GSS codebook, which is easy to access. We just type GSS codebook into Google, and it's going to be the second result. Don't do the 2021 one because that's too specific. And you can see it's very big, right? It's almost 4,000 pages, but you can use Control F. So let's say we're looking for what was one of the harder ones. Let's say maybe something like, I don't know, DAP I. We'll look at that one because a lot of people misinterpret these. So we have to click through a few things, right? This is obviously not correct. Okay, so we come down to the part where they ask about the variable. And we see it just says the woman wants it for any reason. So what does that mean? Okay, well, this is G. Maybe there's a part A. Let's scroll up. Okay, there's a part A. And then we see that there's this baseline question. Please tell me whether or not you think it should be possible for a pregnant woman to obtain a legal abortion if, then we scroll back down, the woman wants it for any reason. Okay, simple. That's how they asked the question. That's how they operationalized it. What about something more complicated? We saw SCI 10 before, and we see, okay, it looks like this could be a little bit tricky. And when we look at socioeconomic index up here for father, let's try to find the first one. We see down here, okay, based on procedures that Otis Dudley Duncan developed, and Keiko Nakao and Judith Treos created a new one, blah, blah, blah. And we're supposed to see this methodological report. You don't need to go do that. I actually, for a higher version of this course as a grad student, did that myself. It was a tedious, although very interesting process. So you don't actually have to go and do that. But you should just be aware of the fact that, and what you can say is there's some complicated well, don't say it like that, but what you should say is something like there is a complex methodology referred to in the GSS codebook that was used to produce this. That's all you need to do. So then your next step is to just double check your paper. You can see the exact metric by which we'll grade the papers towards the end of the project instructions. And you want to make sure that you've done everything in the rubric here. Then export your paper to a PDF. The way to do that is going to vary based on the browser. It can be a little frustrating sometimes, but what you want to do is make sure to bring up some kind of dialog box after selecting print. For many browsers, that'll be under File, Export As, or possibly File, Print, Format PDF. And then you want to print it out and make sure that everything is followed here. So in Firefox, for instance, we can practice doing that here. Let's print out our example paper. So we'll say print here, and you can see we get a bunch of options. We could print the various pages or not. We can save it to different places. So we'll save the PDF here. And in this case, it gives us an option. I'm just going to put this in my folder for this class, and I'll just put it in the main folder. And then we can open it once it downloads. Whoops. Come here, back to here. And we'll look at this here. And you can see this looks pretty good. So I would consider this legible and worthy of being turned in. Okay, it looks like this one here actually got cut off a little bit. So then maybe we want to do something about that and double check if there's not some better way to do it. For instance, one workaround might be this. So Firefox oftentimes prints things like if you just automatically print something like this, you can see that you don't actually get any options. But what if we then try printing this page, because this looks a little bit less formatted, and you can see here, oh, okay, this appears to solve the problem. So that's, I honestly haven't been using Firefox that long. Some of its features are a little counterintuitive, but you can see I was able to just very quickly troubleshoot that and immediately solve the problem just by thinking about, a little bit of how I might tackle this. So not too bad. Okay, so let's come back to setup. Finally, I did decide rather late to require do files, so here's how you should do that. I just wanted to make this clear. It should have the standard header. It should establish a working directory. It shouldn't be more than about 200 lines, which is a generous upper bound. It should be labeled in this way: year, month, date, surname, data analysis, project 1, due. We will take points off for not labeling it in this way because we have to download all these things to grade them, and it gets really difficult to manage them when people just say blah, blah, blah file name. So here's an example. Again, this is worth a certain amount of points, so please don't lose points for this stupid reason. We won't be, I have an extra hyphen here. Okay, that's annoying. But, the point is you need to make some effort at making it look systematic so that we can tell the files apart. Don't just upload something that's your working draft title for it. It needs to run with no bugs, and it should mark off sections with comments, right? So what that looks like is something like this, right? Now this is much longer because I'm explaining what all this stuff does. You don't need to include what the standard header does, but what I want you to do is still explain why you're doing certain things, right? Here's some miscellaneous hints on the first data analysis project. For debugging Stata code, did you Google it and look at least a few Statalist posts? Did you make a working directory and put data there? Did you remember line extenders for multi-line commands? Did you possibly misspell a command or a variable? Did you forget a comma after the command and before the options? Did you look at the help file to check the syntax? Did you remember that variables are case sensitive? Do you remember that missing values are technically infinitely large, so Stata excludes them from most commands, but when you make a new variable or otherwise compare variables, you should be very careful. Did you remember that the single equal sign assigns in most languages, and it is actually double equal sign which evaluates in others? These are all things to consider. Finally, if you picked a variable that has very many qualitative outcomes, a quantitative predictor and a qualitative outcome, or just a qualitative variable that has more detail than you need, you may want to consider making a new variable. Now this works just like the creation of dummy variables, but it can be a little bit more tricky because you now have not just 2 new values of a variable, but 3 or more. If you do feel comfortable with the basic creation of dummy variables and you know how to do it in the simple foolproof way, here's a way you can speed it up. So come up here and follow this general syntax. You say recode old variable name, and then you write the first condition. So old value equals new value. Sorry, that should be new value. Apologies for the typo. So old value equals new value, and then the value label for that. And then you just iterate that until you get to the final value of the old variable, and then you write gen new var. For ranges, you use start end like this. The joiner is a / and a hyphen. So here's how that looks for, let's say, making a new variable that indicates how many siblings someone has. Let's investigate that on the GSS here. So this is sibs. So let's say we have this variable sibs. Note that there's many possible values. And maybe we want to just, this is kind of a stupid example, honestly, because I wouldn't recode it like this in reality, but I just wanted to pick a simple example. So how would we do that? We want to maybe recode it so that people, like, let's say we have people that have 0 siblings should be all in the same bucket. People who have 1 to 5 siblings should be in the same bucket, and people that have 6 or more should be in the same bucket. So we would do that like this. By the way, you don't really need these line extenders here. I just put them in the slides because I want it to be clear that those are all one line. So here you can, you actually technically don't have to start a new line ever, but I think it's a good idea to start a new line before this white space here. So I'll do it like this. So what does this syntax do? It recodes sibs, and it makes a new variable called sibling bracket. And what it does is assign people who were 0s on the old variable to 0s on the new one. And it says none for those people. So it adds a value label. People that were between 1 and 5 on the old variable become 1s on the new variable. And this assignment, by the way, is arbitrary. We're making an ordinal variable, so it doesn't matter. And we say that they're 1 to 5. That's the value label. Then people that had 6 to the maximum of the old variable, we're going to assign to a 2. And we'll say 6 plus for the value label. And then we just add this option, gen sibling bracket. Then we can look at our work. So let's do that here. And it looks like this. And you can see, okay, so we've got none, 1 to 5, 6 plus, and then some missing values here. And now we can compare it to our old variable. This is one way to compare. So we can say tabstat sibs, comma, by sibling underscore. And by the way, we can abbreviate variables. So we can abbreviate sibling bracket with sibling underscore, because that's the only variable that starts that way. And then we fill in the statistics, like we fill in you'll see in a second, we want to print the min and the max of the quantitative variable. So what this shows us is basically a way to check our work. So going by the value of sibling bracket, none, 1 to 5, and 6 plus, we have the minimum is 0 and the maximum is 0 for none. That looks good. The minimum for 1 to 5 is 1, the maximum is 5. That looks good. The minimum for 6 plus is 6, and the maximum is 25. And we can also add in missing values here as well. And you can see that the missing values also don't have any observations that aren't missing. So we're in good shape there. So that's where I'm going to cut this video. I know that was a lot, but please ask if you have any questions about this. Otherwise, I hope this was fairly comprehensive. Thanks so much for watching.